So we're going to be looking at the content needed in order to be able to answer questions from exercise 1A in the further mechanics. We're going to be looking at momentum and impulse in this video. So first of all, the momentum of a body is the product of its mass and velocity at which it's moving. And it's a vector quantity because velocity is also a vector quantity, so therefore momentum will also be one too. And the unit of momentum can be in kilograms meters per second because it's mass times velocity, but we often use Newton seconds instead. And the reason we can use Newton seconds instead is because if you consider Newton's second law, resultant force equal to mass times acceleration, we know that force is measured in newtons, mass in kilograms, acceleration in meters per second squared. And then what you can do is if you multiply both sides by, just rewriting that, if you multiply both sides by seconds, then you get Newton seconds here on the left, being equivalent to kilograms multiplied by meters per second. And that's what we have here. We have kilograms multiplied by meters per second to give us momentum. This is kilograms per meters per second. And so momentum can be measured in Newton seconds. And that's what we're going to be doing. You'll see that people just have Newton seconds as the unit. So let's go through to our first example. We want to find the magnitude of the momentum of a cricket ball of mass 400 grams moving with a velocity of 18 meters per second. So momentum is just mass times velocity there at the top. So here the mass is 400 grams, but in order for us to have Newton seconds as our unit, you can see we will be using kilograms multiplied by meters per second. So we need to make sure that the units are always in kilograms for the mass and meters per second for the velocities. So here we will just change that to 0.4 times 18 to give us a momentum of 7.2 Newton seconds. Then we have a lorry of mass 5 tons moving at 0.3 meters per second. Again, we're going to have to make sure we're in the correct units, changing the 5 tons into 5,000 kilograms. To give us a momentum of 1,500 Newton seconds. So far, relatively straightforward. It's just mass times velocity for momentum. So, impulse. The impulse of a force is the product of the force acting on a body for a given amount of time. Hence why impulse is equal to force times time. It's the amount of force multiplied by how long that force is being applied to this thing. And the unit will also be Newton seconds, and more on that later on as to why that's the same as momentum. And examples of impulse might be, you could have two balls colliding, and so that when they collide, there'll be a force applied from one body to the other for a short amount of time as they collide. You could have a hammer hitting a nail. The hammer imparts an impulse onto the nail. Subsequently, the nail also imparts an impulse onto the hammer because impulses are equal and opposite in direction when two things collide. And a bat hitting a ball. They're all examples of a force being applied to an object for an amount of time. And typically the amount of time that the force is applied is very short. Tennis racket hitting a ball, very short amount of time typically. But there's nothing to say that that time can't be much longer. So, moving on now. What we have here is we're saying that a force, F, that acts for a time t on a mass m that has an initial velocity of u will cause it to increase to a final velocity of v. And I'm just going to write that as a bit of an equation. We're going to use Newton's second law to kind of help us with that. I'm going to rewrite the acceleration as a change of velocity over time, because that's what happens when you apply a force and its velocity is increasing. It's due to the acceleration. And then if we just expand that out a bit, and that's still force. And if you just multiply both sides by t, should have given myself more space, but I haven't, never mind. You can see there that we have force times time on the left, which is what impulse is, as defined up here. Impulse is force times time. We've got force times time, and that is equivalent to two momentums, the change of momentum. Hence why impulse is mv minus u. Hence why impulse, we can refer to it as the change of momentum that a body experiences when it has a force applied to it for a given amount of time. So let's just use this to help us answer a few more questions. So in this example here, we have a body of mass 2 kilograms. It's initially at rest on a smooth horizontal plane. Horizontal force of magnitude 4.5 newtons acts on the body for 6 seconds. And we're being asked to find the magnitude of the impulse given to the body by this force. Now, impulse is equal to, there's two things that we've looked at. We've looked at impulse is equal to force times time. And we also know that impulse is the change of momentum. So the final momentum minus the initial momentum, mv minus mu. For question A, we have enough information just to do force times time to work out the impulse. So that's what we'll do. So we can see that this receives an impulse of 27 newtons per second. And then question B asks us to then find the final speed of this body. So I'm going to quickly sketch a little diagram so you can kind of see what's happening here. So we have this 2 kilogram mass. It was initially at rest. And then afterwards, well, after it received an impulse from this 4.5 Newton force, you can appreciate that the force was hitting it from left to right, then it receives an impulse that moves to the right, and we will then have a velocity afterwards that we don't know, and that's what we're going to try and work out. We're going to try and work out the value of v. Now we know the impulse is 27 Newton seconds. We worked that out in part A. So another way of working out the impulse is that it's the change of momentum. So it's going to be mv minus mu. So we can just substitute the information in. So we know the impulse is 27. We've taken right as positive. So it's going to be 2 times v, take away 2 times 0. So we're left with 2v being equal to 27, and therefore that velocity being 13.5 meters per second. The question, of course, asks for the speed, so the speed is 13.5 meters per second. And the reason why the question asks for the speed is because had I taken the positive direction to be left based on the diagram that I've drawn, then I would end up with a negative velocity, just to indicate that things were going in the opposite direction. So that's why I asked for the speed. But either way, you would take the magnitude of the velocity and you get 13.5 meters per second. So let's take a look at one last example. So here we have a ball of mass 0.2 kilograms hits a fixed vertical wall at a right angle with a speed of 3.5 meters per second. The ball rebounds with a speed of 2.5 meters per second. And we want to find the magnitude of the impulse exerted on the wall by the ball. So first thing I'm going to do here is draw a diagram. So I have a mass here of 0.2 kilograms. It's going to hit a wall. It hits the wall with a speed of 3.5 meters per second. So I write that there, and what I'm doing is I'm writing the before above the diagram, or above the particle. And I did that in the previous example with that kind of clarifying. This here was the before, this here was the after. And so it hits it with 3.5 meters per second, and we know it rebounds at a speed of 2.5 meters per second, so we know it goes backwards now, back off the wall. And we're being asked to find the magnitude of the impulse exerted on the wall by the ball. Now, the impulse exerted on the wall by the ball, we can't calculate. Because we want to work out the impulse that the wall feels, then we need to know its mass and its velocity before collision and velocity after collision. But we don't know any of that information. So we can't work out the impulse on the wall directly. But because when the ball collides with the wall, the wall will feel an impulse going that way from the ball, but the ball will also feel an impulse going that way due to the wall. And these two impulses will be equal and opposite direction. So in order to work out the impulse on the wall, we instead work out the impulse on the ball because it will be the same. So considering the ball, I'm going to take right as positive. Impulse is the change in momentum, mv minus mu. You can then work this out. And we get 1.2 Newton seconds. So that is the impulse that the ball feels. I've actually done that wrong, haven't I? I've got my velocity the wrong way round. The reason I realised that was wrong was because I didn't quite have the impulse wasn't positive. Should have been negative, and I'll explain why it should be negative in just a moment. So 0.2 times the final velocity, take away 0.2 times 3.5. So that gives us negative 1.2 Newton seconds. So we have a negative impulse, and the reason we have a negative impulse that the ball is experiencing is because we took right to be positive. And so it's saying, our calculation here is saying is that the impulse that the ball is feeling is going in the opposite direction, it's left. And that's what we expect. We expect that impulse, once it hits the wall, to be going to the left. Now, the question was, find the magnitude, find the size of it. So the ball feels the same thing. Still, the ball feels 1.2, and so does the wall. The wall also feels 1.2. So therefore, the impulse that the wall feels, its size is 1.2 Newton seconds, and it would be to the right. You can now answer some of the questions from exercise 1A. Best of luck.